Hey everyone, this is my submission for the 2024 Congressional App Challenge, and the name of my website is called PolypDetect. So in order to understand the relevance of PolypDetect, I first want to introduce you to what polyps are and what machine learning is. So polyps are small cluster cells that grow on the lining of the colon. Pseudopolyps are a type of polyp that result from chronic inflammation in the colon, and they're often found with patients with inflammatory bowel diseases such as ulcerative colitis and Crohn's disease. Polyps and their subclass pseudopolyps are both major indicators of major health conditions such as cancer and inflammatory bowel diseases. If a polyp is cancerous, it can lead to death, and if there's pseudopolyp, if it's not detected early, then the patient could be stuck with lifelong symptoms of IBD, such as diarrhea, fatigue, severe abdominal pain, and many other symptoms. And as pseudopolyps are often hard to detect in comparison to actual polyps, and actual polyps themselves are even harder to detect, with only around 32% of polyps being detected during colonoscopies, it's really difficult if these patients get late diagnoses, as it could severely affect the outcome. So the aim of this project was to develop a machine learning model that can detect these polyps and integrate that model into a website nicknamed PolypDetect so that it can be used by patients and healthcare professionals. So machine learning is a subset of artificial intelligence that uses algorithms, statistical models, and trained data to make predictions without being explicitly programmed, and has many applications in healthcare as it can allow for quick and accurate diagnoses. So essentially what machine learning does is that you give it some trained data and then you teach it what it needs to classify. You teach it what it needs to do. Once you teach it what it needs to do, now you can apply that model for other tasks. So in this project, I used a convolutional neural network, which is the type of machine learning model. And what this convolutional neural network does, or CNN, it classifies if an image is a polyp or not a polyp. And so the purpose was to create this CNN that can detect polyps with an accuracy greater than 90%, and then integrate this machine learning model into a website. So to develop the machine learning model, I used Python. To develop the UI for my app, I used HTML and CSS. And then to host my app, I used Streamlit. And so before we get into the app, I just want to explain kind of how a convolutional neural network works. So essentially what happens is you give the convolutional neural network a inputted image, and then from that inputted image, there are different layers which extract features, and these layers are called convolutional 2D layers and max pooling layers. Then these extracted features are passed to the neurons in the dense layer, and these neurons perform specific calculations. They kind of determine the weight of each feature in determining the output for the model. And based on these calculations, whatever weight that feature has, the model will take those weights and then it will produce an output, either saying it's true, meaning it has a polyp, or it's false, meaning it doesn't have a polyp. So next, I want to show you how my website works. Alright, so this is the app that I created, and it's nicknamed PolypDetect. So essentially what it does is it integrates the previously trained convolutional neural network, which had an accuracy of 92%, and it allows that model to perform its predictions on uploaded images and videos, as colonoscopies are often in video format as well. So essentially what the user can do here is they can click on Browse Files, and from there they can choose an image. So this test polyp image has a polyp in it. So if we upload that, we can upload the image, and then we can click on Detect Polyp. And what the model will do is it will give us back its prediction. So if it's true, that means there is a polyp. It'll show us its output. So if it's greater than 0.5, it's going to believe that there is a polyp. But if it's less than 0.5, it's going to believe that there's not a polyp. And then it'll return the originally inputted image. And this is where the polyp is located. Similarly, if we upload, let's say, a normal image with no polyp, we can upload the image, click on Detect Polyp, and then we can see that it's giving us a false prediction. Similarly, we can do this for more discrete polyps, for example, an ulcer perhaps, where there's a small polyp growing in this image. And it'll also be able to predict these very small polyps. So if you see right here, there's a very small polyp growing, which can often be missed during colonoscopies. So the earlier we can detect these, the better it is. And finally, this also works on videos. So if I upload this video of a colonoscopy, we can see how the model, essentially what the app will do is it'll break down that video into different frames, and the model will perform predictions on each frame. So as soon as it uploads, you can see down here, you can choose the frame number. Right now, there's no polyp, so it's detecting false. But let's say we go to frame 150. Now there's a huge polyp right here, and the model is able to detect that it's there, so it's showing that it's true. This app is not only limited to that, but it also has an information page where it discusses about polyps and machine learning and more about inflammatory bowel diseases. There's also a comments section for users to upload their own comments, so they can write their name here, and then they can type in their comment. So I'll type in hi, and then they can submit their comment, and then if they want, they can also delete their comment by clicking this button down here. And finally, there's also a QR code page if you just want to send this app to anyone else quickly, and it's a quick way to access the website. And this app was developed through GitHub. So as you can see right here, this is the app.py page, which is the main part which has all these sidebars. And I also use Streamlit to kind of help with designing. And then this is the comments.txt, which is where all the comments get saved. Here is the information page. And then the packages, this is the QR code image, and then all the requirements needed for the setting up for the app. So thank you so much. I hope that PolypDetect will serve as a really important tool in the future that can be used by many doctors and help to prevent any late diagnosis in the future. Thank you.